problem, sound glitch, what I'm going to do is I'm going to re-record this video. All right, so we're going to go back in time all the way to the beginning, if possible. Okay, we can't. All right, so looking at corresponding co-interior and alternate angles. How do we tell the difference between this? The first thing I'm looking at here is when it comes to corresponding angles, we can think of it like a shelf of books. And the book that's in the bottom left-hand corner are all in the same position. And we say that those angles are corresponding to each other. You can see there in that corner at the top. And on this side, these angles will also be corresponding as well. And that's how the F shape is formed. Here you can actually see the F shape working like this, upside down. Here you can see the F shape as well. And then likewise, the top angles will also be corresponding in each of these. So corresponding angle is the F shape, and that's how it would work there. If we're looking at something like this for corresponding angles, in this instance, we can see that each dot or each point is where the lines meet will have 4 parts to it. And I label each of these 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. 1 at the top, 2 to the right, 3 down, and 4 left. And by doing this, I can see that 1 is corresponding this way, and 1 is also corresponding that way. And over here. And if I go to the next one, which is 2, 2 is corresponding over here, and 2 is corresponding over here. 2 will be corresponding over here, and 2 will be corresponding over there as well. And then we've got 3 corresponding at the bottom, 3, 3, 3. And then lastly, 4 is corresponding on the left. That's all the 4 that's corresponding on the left. And you can see corresponding angles are in the same position, but at another point. Looking at this one over here now, what we have here is each of these angles, each of these points. If I am given that this is, if I'm told that one of the angles is 80 degrees, then automatically vertically opposite angles where 2 lines meet will be equal, and corresponding angles will cause this to be 80, that to be 80, and that to be 80 as well. As well as 100 degrees, which is going to be angles on a straight line, because these 2 angles add up to 180, will then cause those 2 angles to be corresponding, and likewise those 2 angles to be corresponding as well. And then vertically opposite angles will cause that to be 100, that to be 100 as well, because there's again a crossroad, and these 2 angles are opposite each other. So every single angle in this entire shape will either be 80 or 100 and nothing else, given that these 2 lines are parallel and those 2 lines are parallel as well. So that's corresponding angles. When it comes to co-interior angles, we're looking at the U shape. Now this is not a U, this is more like cornet, right? It's not exactly a U shape, I would say. But we can see that this corner and this corner, these 2 angles will add up to 180 degrees every single time. So co-interior angles exist inside, and that's where the word interior comes from. So you have 2 angles which are on the inside, and they add up to 180. So that means this angle could be 80, this one would be 100. And why did I choose this one to be 100? Because this one is obtuse and this one is acute. And I could change this out. I could make this 70, then this becomes 110. I could make this 60. This will become 120. If I make this 50, this will become 130. No matter what, you can see that these two always add up to 180 degrees. And as I reduce this angle to, let's say, 50 degrees, this angle will increase to 130 degrees. And there will always be co-together interior on the inside. Co-interior on the inside. And that's where all of these angles are coming from. All on the inside, over here, like that, there, and there. Over here, I've got a parallel symbol, but the lines have to be parallel. What happens if they're not parallel? What will happen if the two lines are not parallel? What if you got a line like this, and a line that goes slightly this way? Okay. If these two lines are not parallel, then this angle could be 110 degrees, and this one could be 20 degrees. And it won't add up to 180. Therefore, these two will not be parallel. That's impossible. So to go backwards, if this was 160 degrees and that was 20 degrees, then we could say that that would be parallel. All right. The next one is alternate angles. Alternate meaning like another route. So what I have here, I am driving on a car. Okay, so let's get a car going. So I've got a car. Here's my wheels. Okay, and I'm going to take a drive. But all of a sudden, there is an accident on the road, or something, incident, or a roadblock because there's a puddle. I travel in this direction, and I have to now take an alternate route. I have to take an alternate route. So I go this way, and I go parallel to the route I was going in so I can reach my destination. And so by changing, I have to take some kind of alternate route through maybe some scenic spaces. And the angles that I make when I do that will cause the alternate route will be caused by the angles that I make, which will be equal and not adding up to 180 this time. It's equal. So you'll notice corresponding angles are equal. Alternate angles are equal. But co-interior angles add to 180 degrees. Okay. Co-interior angles add to 180 degrees. These are other types of alternate angles. This is an obtuse alternate angle. Again, I'm driving, and all of a sudden, okay, you know what? I need to pass a gas station, which is over here. All right, I'm going to fill up some fuel. And so I take an alternate route, keep going in the same direction because it's going to reach my destination so I can pass the gas station. And then maybe I go back on the route again, and I go to where I was. So in this case, these two angles will be alternate. And this is where the Z shape comes in. So the Z shape comes in when we can see, in this case here, the Z shape is not, it's upside down and it's obtuse. It doesn't even look like a Z. All right. Here's another form of alternate angles. And it's on the inside. It's not on the outside. So if you're going outside, it's not what it is. It's on the inside. So it's where you're turning. If you're driving and you're turning this way, it's the angle on the inside. And then you're turning this way, it's the angle on the other side on the inside. As well as here, and there, and back this way, producing alternate angles. Vertically opposite angles, these two angles will be equal, and those two angles will be equal whenever you got two straight lines, and these lines can be obtuse or acute. Then we would say this angle is equal to this angle, and this angle is equal to this angle. Suppose this angle is 20 degrees. This automatically becomes 160 degrees because angles on a straight line add up to 160. So this is 20, this will become 160. So you have two ways of working it out. You have angles on a straight line and you have vertically opposite angles. There's a reason to calculate those angles there. That's it. And now we have our corresponding co-interior and alternate angles done.